right, so as they're joining, I'm going to do a share screen. I just want to point out kind of how this goes. If you're not familiar, you didn't really join in the Zoom's first semester, let me go ahead and kind of point out what I will spend my time doing each time. Or if you haven't had a chance to go and watch the videos, I am going to start putting the videos on my YouTube channel. So I'll send you the links to them there. If you subscribe to it, then you'll automatically be able to get it. So that will be kind of nice. But that's where I'm going to keep them all in one place, and I'll label them according to the topic. But I just want to point out what we're going to be talking about today. So today is Tuesday. So we will either go over an instruction, which today there's an instruction on our schedule. Tomorrow's an assignment, so I will go over problems from the assignment. On Thursday, it's a quiz, so I will go over problems from the quiz. So you can see the topic, and then on Friday, it's an instruction, so I'll go over the instruction for the law of cosines. So again, I will only focus on instruction, assignment, and quizzes. I try not to have them on the same days, like a quiz and an assignment on the same days. I try to separate them. Sometimes you might have an instruction and an assignment on the same day. I've tried my best not to let that happen, but I can't always control that. So if anything, if I need to take out something, I will take out an instruction and still go over the assignments and the quizzes. So I may not go over the instruction every time. It just depends on that week's schedule. Again, this is what you want to go off of. It's the week at a glance. It will be pretty close to what it is in Edgenuity, but if it shows you're behind in Edgenuity because what I told you is different, that's okay. Don't stress about it. If it turns red, don't freak out. You're fine. Just keep working. If you keep following my pace, you will be perfectly fine, and it helps you from being so overwhelmed on one day versus the other. So sometimes they bunch up like 3 assignments on one day, and you might have nothing the day before, and you might end up doing it like that. But when I go over topics, I'm trying to help you guys break it up. So let's go ahead and hop into today's lesson. Let me switch my screens here. So when I go over these lessons, I usually will have it set up on notes. So you can choose to copy these down. These could be part of your notes that you turn in. You don't have to do notes as you're going through the lessons, although you can. And when I do these problems, you do have your lessons to watch. You have your own instruction to watch. So I try not to be super repetitive. They will do a lot of the background of where the things are derived, how they happen, so you'll get a better understanding. I'm just kind of taking the bits and pieces of it, focusing on here's the formulas that you're going to be using. So it's kind of more here's the nitty gritty of it. Here's what you need to know. But the background and a lot of the meanings are in these videos. So I highly suggest that you watch them. Well, you have to watch them actually to progress, but just so you know, as you're going through them, a lot of times the problems are the same. If you have any questions at any point, you can unmute yourself. You could jump in. I don't care. I want you guys to be able to understand it. If you want to put it in the chat, a question in the chat, you can always do that as well, whatever you prefer. As we go through this, there'll be things that you'll need to do on your calculator. So make sure you have a calculator. If it's graphing, I hop onto my Desmos a lot, and I will show you guys how to use some of this stuff as we get to it, whenever it occurs that you guys need to use it, which you will in this unit. So this is a big unit. It's a lot of information in this unit. If you've had Math 3 last year, this first couple sections will just be a review, which is nice, especially coming off a break. But let's go ahead, let's hop into it. So we're going to be talking about the law of sines. So what is this law of sines? Well, the law of sines helps us to find a missing side of a triangle. So if I have some triangle A, B, C, then remember, across from my angle A would be my side A, across from my angle B would be my side B, and across from my angle C would be my side C. I use the law of sines if I want to find a missing side or an angle, but it has to be for a specific kind of triangle. So this only works for triangles if you're given an angle, and a side, or an angle, a side, and an angle. So in other words, if I'm given angle A and angle C and side A, then I could use what we call the law of sines. Or If I'm given my angle, my side, and my angle, so they have to be all consecutive or all in a row. So an angle, a side, an angle, if it's given that information, then I can use the law of sines. Some of you guys are like, well, can't I just use SOHCAHTOA, right? Can't I just use my SOHCAHTOA to find a missing side of a triangle? Well, yeah, I can, if it is a right triangle. So if I know an angle and I know one of my sides and I want to find another side, I can use SOHCAHTOA if it is a right triangle. So remember, this only works for right triangles. This works for any type of triangle. This works for triangles when we don't have a right angle. So what exactly does that formula look like? Here's going to be the formula you're going to want to use. I have side A all over sine of angle A is equal to B all over sine of angle B. So these two are equal. It's also equal to C all over sine of angle C. In other words, I can have A, my side A over sine of A equal to my C over sine of C. I can have this combination, or I can have this combination. They're all equal to each other. And this right here is what we call our law of sines. So for this first unit, you're going to be using this over and over and over again. Okay, well, let's kind of review some more things about triangles. It says, what is the measure of angle A in the triangle? Some of you guys are like, well, that's really easy, but sometimes we forget those little pieces. Because remember, all angles in a triangle have to add up. So we're looking for this angle here, and all the angles in a triangle have to add up to 180. So all angles in a triangle add to 180 degrees. And some of you guys are like, oh my goodness, that's so silly that I'm spending the time to do this. Again, it's just those little things that we just kind of forget. We're like, oh, it's 360 because the circle's 360. No, just kind of reviewing, it's 180. So if I want to figure out what angle A is, I would do my 54 plus my 82, and that's going to give me 136 degrees. So these two angles add up to 136. Then the measure of angle A is going to be 180 minus my 136, and it's going to be 44 degrees. Easy peasy, right? They actually had the word degrees here, so I didn't need my degree symbol, but make sure you were using proper notation. Sometimes things in this unit are going to be in degrees, or you might also see things in our radians. So you want to make sure you're using the right units. All right, so let's get into this law of sine stuff. Some of you guys know what this image is. It's the Leaning Tower of Pisa. So it says the Leaning Tower of Pisa in Italy leans at an angle of about 84 degrees. The figure below shows 52.1 meters from the base of the tower, and the angle of elevation to the top of the tower is 50 degrees. So this is our angle of elevation. When we look straight out and we go up, that's an angle of elevation. Find the distance B from the base to the top of the tower. So the goal is to find the distance B from the base to the top of the tower. It says, what is the measure of angle C? That's just part of having you guys solve it, but that's not the main piece of it. So I'm going to kind of show you how to go about this. My first step for all of these problems, and this will be different than how you see it in the video, but this is how I always teach it. And I think it helps you guys organize your information best. Some of you guys are like, oh, I don't need to do that. But then we're going to get into the law of cosines coming up, and we'll help you visually see, what do I use law of sines? Do I use law of cosines? And the differences. So my recommendation is always to set it up like this, where I figure out I have my angles A, B, C, and I have my side A, B, and C. So I create a little box of information. So I look at my picture and I say, okay, well, what of this information do I have? So I know that my angle A is 84 degrees. I know that across from my angle C, this is my side C. My side C is 52.1 meters. I know my angle B is 50 degrees, but I don't know, they didn't give me straightforward. They didn't tell me what my angle C is, and I don't know my side B or my side A. Side B is what we're looking for. Okay, so I'm going to use my law of sines, but the trick for law of sines is I have to have what I call a complete set. What do I mean by a complete set? I have to have my angle and my side, corresponding angle and corresponding side. So when I look here, I know my angle A, but I don't know my side A. I know my angle B, but I don't know my side B. That's what we're looking for. I don't know my angle C, but I know my side C. So I don't have a full set, but I could very easily. And this is why they gave you this in here to find the measure of angle C. Because I know these two angles, then I can easily find my angle C. So my first step here is to find angle C. And this is easy. It's going to be my 84 plus my 50, which is going to be my 134. And then it's my 180 minus my 134. So that has to be 46 degrees. So this has to be 46 degrees. That's an, oops, sorry, you guys. So that has to be the case. Again, you guys could copy down these problems. You could copy down the triangle and the work I'm doing, and this can be used as part of your notes. You need to have 1 page minimum for each section. So this is one section is the law of sines. Okay, so I go ahead and I look at this and I go, okay, I got my angle C, and I was talking about this idea of a full set. When I look here now, I would call this my full set where I have my angle and corresponding side. This is my full set. So in order to use my law of sines, we need a full set to use the law of sines. So I'm going to go ahead and use my law of sines now to find my side B. And here's what this would look like. My law of sines, so I want to figure out this piece right here. So I need to be using my value of B, and I have my C's. So if I'm going to use my law of sines, it's going to be C all over sine of C. So I use my full set that I have, and I'm looking for B, which has to go over my sine of B. So again, I have my full set. I'm looking for my B, and I know my sine of B, so I'm going to plug in all of my known pieces. So what this is going to look like is it's going to give me 52.1 all over sine of 46 degrees is equal to B all over sine of 50 degrees. Now, in order to solve this, I'm going to go ahead and I would cross multiply. If two things are equal to each other, if I have two fractions equal to each other, then we can cross multiply. And the way that this would turn out then is it would be B, and I like to write it out in front, times my sine of 46 degrees is equal to 52.1 times sine of 50 degrees. I'm solving for B, so I want to get B by itself. So I'm going to divide both sides by sine of 46 degrees. Sine of 46 degrees. And I end up with B is equal to approximately, wow, I gotta put this in my calculator. So let's see how this looks. How would I put this in my calculator? First, make sure you are in degrees and not radians. Make sure you're in degrees. Okay, so then I would do 52.1 times my sine of 50 degrees. And I like to just hit my equals. Sometimes you guys mess up your order of operations. So this is just the numerator right now that's in the calculator. Then I'm going to divide it by my sine of 46. And when I do that, I get 55.5 meters. So make sure you round correctly or your answers will be off. So it's going to be 55.5 meters. And that's the answer for our missing height there. Kind of a lot to take in for that first example. I understand that. So you're kind of cluing in on what are you looking for, the idea of the cross multiplying, and again, practicing your order of how to put this into the calculator. Calculator errors are usually your biggest mistakes. It's usually where you guys go wrong. So as we do this, I highly suggest that you have your calculator handy and that you practice with us. All right. So that was kind of the basics of law of signs, but it gets a little bit more complicated. That happens when we have what we call our ambiguous case. It's called our ambiguous case of the law of signs. And that's when we have an SSA triangle, where I'm given a side, and an angle. And I always say that these ones are a pain in the, and if I took my SSA and I read it backwards, you would see what that spelled. These are the ones that are a pain in my SSA. Why are they a pain in my SSA? That's because if I'm given a side, and an angle, I can have a triangle that is not created. I can have a right triangle. I can have a scalene or isosceles triangle, something like this with one triangle, or I can have measurements that would create two different triangles. So if I have a side angle given to me, then I could possibly have two different triangles. I have 4 different scenarios to look at. So I need to figure out, well, how does this work? So these ones, again, there are 4 different scenarios. So this is when you have 2 sides and a non-included angle. Some of you guys think, what's an included angle? An angle between the 2 sides. So an included angle is an angle that's between the 2 sides. So when I have a triangle, if I have this side and this side, then the angle between the 2 is this angle. That one's what this would be what we've called the included angle. So when it's not the included angle, then those are the ones that are going to be a pain in my SSA. All right, so the other piece to this is, here's the shortcut to figure out, how do I know what kind of scenario I'm going to have? So if I have an SSA triangle, if I figure out what H is, that's going to help me determine, do I have no triangle, a right triangle, 1 triangle, or 2 triangles? So again, here's your information that you're going to use to determine the number of triangles, is this box right here. So again, this is all the instruction. Tomorrow we'll go through more just examples of it, but this is kind of your lesson within this. So it's a lot, again, to take in, but we've got a couple days to practice this and look at it. But these things that I boxed are the things that you should keep handy as you're going through the lessons. These are the things you're going to keep referencing, your formulas you're going to need. Okay, so here's what's happening. It says, given the measure A is 10, B is 40, and angle A is 30 degrees, how many triangles can be possibly formed? So in order to figure out this, I want to figure out what my H is. So I have H is equal to B sine of A. So H is equal to 40 times sine of 30 degrees. Go to my wonderful calculator, and I have 40 times sine of 30, and that's going to give me a value of 20. So my H is equal to 20. Now there's some things to look at. So every one of these is dependent on my H value. So I want to see, how is my A and my H related? So B is the one that was inside my formula. A is the one that's not. It's the leftover. That's what you're comparing. So I have my A was 10, H was 20. So I have A is less than H. So there's only one scenario where A is less than H, which is right here. So this means that there are there is no triangle. Some of you guys think, well, how can that happen? How can I have no triangle? Well, that can happen if I know the length of this side, I know the length of this side, and I know an angle here, but this side may not be long enough to connect. It's missing a piece there. The one side's not long enough, so it's not going to enclose the figure. So you know what this angle is, and you know that this line has to be here, but this one's just not quite long enough. So it's missing the piece to enclose it, and that's why we have no triangle. Okay, so let's try it again. Now they switched this up on us because my formula H is equal to B sine of A, but there's no A here. So how does that work? Well, again, so look at the pattern. My angle was not the same as my side. They were not corresponding. So in this case, we would want to use H, and instead of A and B, this would actually be my C sine of B. So notice the side and the angle are not going to be the same. So my side and my angle are not going to be the same. If you prefer, some of you guys might actually like to go and you might change this to an A and an A just for your formula purposes. That's okay. If you don't visually see how it's changing, you can go ahead and do that. So let's plug in the values. So H is equal to, it's going to be 8.9 sine of 63 degrees. And I'm going to tell you that that's going to be approximately 7.9. So then I need to compare this value here to my H. So be careful, because when we look here and you see this B, it's not the same as this B. Remember, this B is acting as that A. So I know it gets confusing. So if you want to change them so you can compare, you can. So when I look here, I'm comparing my 10 and my 7.9. So this, my B is 10, my H is 7.9. So I know that this value is greater than, oops, my H. It's greater than. So that means it's going to be one of these two. And again, this throws you guys off because you're like, wait a second, I'm using B. But remember, it's not always, it could be a triangle Q, R, and S. So you need to know how to apply them and what you're looking at. So as A and H are comparing this leftover side to that H value. So then when I look at this, I go, okay, well, it's one of these two. Well, now when I look at this piece over here, this leftover angle is what's being compared. So is that leftover angle greater? Is this greater than? Which one's greater? So in this case, B is equal to 10 and my C is equal to 8.9. So this is telling me then that I have my B is greater than my C. So in this case, it's going to match up to this piece right here, which is telling me I have one triangle. Again, you could have changed this to A, B, and A and done it that way so that it matches better with this. That's a personal preference. There's not one way isn't better than the other. All right, my last example for the day. I try to keep these to be within 30 minutes, and sometimes they're 20, sometimes they're over, but I do try to keep them as short as possible because I am taking up some of your time, but I want to make sure I get through enough information so that you guys have a good foundation and you guys are good to go. So this is one of the trickier problems. This is the trickiest that you'll see. These are the most work. Sometimes, again, when we're asked to solve a triangle, it could be no triangle. And we're like, oh, there's no triangle. You're done. You can't solve the triangles. But sometimes there's going to be two. So how does it work if there's going to be two triangles? And in this case, I'm going to work that out. So okay, so let's go ahead. Let's look at this. So it says, I have a triangle ABC. So again, I like to set up my information. So I have my A, B, C. I have side A, side B, side C. So I'm given triangle ABC, so I know I'm going to have this table here. It says solve the triangle if any exist. So I'm gonna fill in what I do know. I know that this angle is 49 degrees. This is 110. This is 125. These are my pieces that I don't know. So when I look at this triangle, if I want to label this A, B, C, this is my side A, side B, side C. Let me just kind of visually show you. I have a side, and an angle. An easy way to tell my law of sines, it's when I have two missing angles that I have to worry about it being the SSA triangles, the ones that are going to be a pain in my you know what. So, and I look here, I know my A, I know my C, and I know my angle A. So again, this is in side, angle, triangle. This is what we call an SSA triangle, SSA triangle. Sorry, try not to read it. You guys want to read it this way? I will always try to refer to it as SSA. I don't want to get myself in trouble. But these are the ones that I need to check then. Does it have no triangle, 1 or 2? So let's quickly check that. So in order to check that, I needed to figure out what H is. So H is going to equal, it's going to be, since there's no B, it's going to be my C this time. It's going to be 125 times sine of 49. So H is equal to 94.3. So I'm comparing my A, which is 110, and my H, which is 94.3. And this tells me that A is greater than H. So I know it's one of these two then. A is greater than H. Then I looked at what my other value here, my 125. So my A, again, was 110. My C is 125. And I compare and I can see that my A is greater than my C. Sorry, it's not greater. My A is less than my C. And so I can see then it's going to match to my two triangles. It's going to match to two triangles. So I know I have now two triangles I need to solve. Two triangles. Okay, no problem. I've got this. So this is going to be my first triangle. So this will be, we'll have this be triangle number 1, which means I've got to have a triangle number 2, right? So over here, I'll go ahead and I'll do my triangle number 2. So for my second triangle, I still have an A, a B, C, A, B, C. So I labeled it all the same. Now, when we talk about the second triangle, these values don't change. They're the same in both triangles. So I know that this is 110. I also know that my C is 125. I know my A is 49. What I don't know, again, is my B, C, and B. But this B is going to be different than this B because they are two different triangles. The given information has to be the same, but these values are different. So I need to label them differently. And what we do that is we do this little markup here. A little markup there, little markup there. And we call this B prime, C prime. This is my lowercase b prime, so that they're not representing the exact same angle because they're going to be different triangles. So this over here is going to give me my second triangle. Okay, well, how do I do this? How do I figure it out? So I'm going to focus on my first triangle right now. And this is going back to how do we do our law of sines? Well, remember, law of sines, if I see a full set, I can use my law of sines, and I see that. So here's my full set. So I want to go ahead then, and I'm going to solve for my angle C. Why am I going to solve for angle C? Well, if I try to solve for B, I don't know either B, so I would have two unknowns. So I have to solve for C. So I'm going to solve for angle C first. And the way I'm going to do that is I'm going to do, I'll write it out for you guys just to kind of get you guys more familiar with them, and do A over sine of A is equal to my side C over sine of my angle C. So I fill in my pieces. So I have 110 times divided by sine of 49 is equal to 125 all over sine of C. And then just like we did on the front, we're going to cross multiply, and I get 110 sine of C is equal to 125 sine of 49 degrees. I'm going to divide both sides by 110 because I want to try to get the C by itself. So this tells me that sine of C is equal to, I go to my wonderful calculator and I'm going to do my 125 times sine of 49 divided by 110, and I get this number of 0.0576. And you guys are like, well, how does that help me? Well, if I'm looking for the angle, remember that we've got to take the inverse of it. If I want just C, then I need to take the inverse. So remember, what you do to one side to get rid of that, C, I would need to do to the other side. So it ends up being that C is equal to sine inverse of 0.8576. So I go to my calculator and I just do shift sine. So that gives me my inverse. And then I have an answer key right here. So I'm just going to hit my little answer button. So it takes that number that's already there. And it tells me then it's going to be 59.1. They use, from the most part, they use the whole numbers. They just round it to the nearest whole number. It doesn't always tell you. Most of them are that way. Sometimes they rounded to the tenths, and I wish they were more consistent. So for the problem like this, they just rounded it to the whole number. So this is going to be 59 degrees. Is approximately 59 degrees. Okay, so I found that first angle. This is what helps me figure out the rest of my other triangle as well. As soon as I find that, as soon as I find this first angle here, that first unknown, I know you guys can easily find B now, but as soon as I find that C value, I want to find my C over here. So as soon as I do this piece, and I know this is going to be 59 degrees, then I want to find my C prime. And the way that I do that is I do 180 degrees and I subtract 59 degrees. And when I do that, I get 120 degree, sorry, I had rounded numbers here. So it's 121 degrees. So this value then is 121 degrees. It's going to be 121 degrees. That's how you find your C prime. Once I find this first angle, then I have my first angle for my second triangle. I know it's a lot to take in. The rest is just keep on going using your law of sines and the information you know. So if I want to go for my angle B, easy enough. I know the two sides, so it's going to be 49 plus 59 is going to be 108. So then it's going to be 180 minus my 108, and that's going to be 72 degrees. And then I would use my law of sines now to find B. So some of you guys go, well, which one do I use? I could use this set, or I could use my C's now. I usually always stick though to the first one that I use. So if I started off with this one, I always stick with my sine of A's. So if I want to find my side B now, I would do my sine of A over, or sorry, A over sine of A, which is 110 all over sine of 49 is equal to my B all over sine of 72. So again, this is my A over sine of A. I usually stick with it. You could have used your C, it doesn't matter. And then we cross multiply. So I have B sine of 40 degrees is equal to 110 sine of 72. Divide both sides by sine of 40. And this tells me B is equal to, I go to my wonderful calculator, I would do 110 sine of 72 equals divided by sine of 40 equals, and I'm going to be at 100. And did I type that in right? Oh, that's a 49. I just copied it down as 40, so my bad. It is a 9 there. It's 49. This is 49, 49, 49. That would help. So it's going to be 110 sine of 72 divided by sine of 49. Much better. That's going to be 138.6. So, and then I go over here, I finish this off, same idea as what we did over here. We've got to do our B. So for our angle B prime, I know my two sides. I have 49 plus 121 is going to be my 170. So then it's going to be 180 minus 170, which we probably don't need to write out. So I'm going to have this as 10 degrees. And then again, your law of sines. So I'm going to use my full set. This is the same full set that you've been using because they're the same values in the triangle. So if I want to go for my B prime, it's going to be 110 over sine of 49 is equal to B prime over sine of 10 degrees. And I cross multiply. And you can see how repetitive some of it is. So you'll get to see the patterns and you get a lot quicker with it. Remember, if you're solving for an angle, you're going to use your inverse. If you're solving for a side, you don't have to worry about that. So it's going to be B sine of 49 degrees is equal to 110 sine of 10. Divide both sides by sine of 49, sine of 49. And my side B is going to be approximately, my calculator, it's going to be sine of 110 sine of 10 divided by sine of 49. And it's going to be approximately 25.3. We survived it. Day 1 of lessons. Again, tomorrow we're going to be working more with these and on Thursday. So don't feel too overwhelmed today, especially with these double triangles. Again, the biggest thing I cannot stress to you guys, once you find your first angle, find your first angle for your second triangle. This is always the hardest part for you guys, is finding that second triangle. If you guys have questions, please let me know. Put them in the chat. Ask me anything right now. If you guys need a clarification along the way, I will not be upset if you put something in the chat, or if you unmute yourself like, hey, where did that value come from? Or when I wrote this as 49 and you're like, wait, Miss Acevedo, or when I wrote it as 40, correct me, hey, it's 49 there, because I make mistakes. So if you guys don't have anything, then I will see you guys tomorrow. I hope you guys have a wonderful day. Make sure you sign into Edgenuity today. If you don't sign into Edgenuity today because you're waiting to do it tomorrow, then make sure that you do fill out the form in Google Classroom so I can mark you present for the day. All right, you guys have a great day. Take care.
Have a good day.
Thank you.